In this session, we're going to watch an actual video of on-site interview so we can see how the interviewee interacts with the interviewer and how he approaches the technical problems. Let me introduce the candidate. He got his bachelor's degree in computer science, and while he was in college, he had one software engineer internship experience. So he is not a real, fresh, new grad. So please consider his engineering background. Let me tell you the interview questions that I have asked. I asked 3 questions. First one is to reverse the vowels in the given input string. So basically, he's going to write a function, and the input to the function is an input string, and then output is also a string that has the vowels in the reverse order. And the second question is that in the library, in a physical library, we have millions of books, and we know the order of all the books, and we want to reverse all the vowels of all the books in the library, saying that the first vowel in the first book will go to the last vowel of the last book in the library. The third question is that for the 2 input strings, the interviewee is asked to find out the inserted character. Let's watch. I just looked at your resume. You did really fantastic, and thank you so much for for the position on my company. I'm a software engineer at company A. I'm Jeff Bay. I'm working on the really interesting computer vision project. So we have an opening position in my team. We will have the multiple software engineering jobs. One is the pipeline design and database design, computer vision algorithms, and so on. This is really perfect. This is a 45-minute on-site interview session that will ask several coding algorithm interview questions. Do you have any question before we start?
I think I'm all set.
Okay, great.
Go ahead and start.
Okay, so the first question that I have is I want you to look at the string and to do some processing. For example,
Sure.
I have word apple.
Yes.
And then I want you to write a function to reverse all the vowels. So E, P, P, L, A is the output of that function.
Okay.
Okay, and another example is the friend.
Yes.
And the output is the F, R, E, I, N, D.
So we just need to reverse the vowels and leave the rest in place.
Yes.
Okay.
It's up to you. It's up to you. You can do the in place reverse, or you can do whatever you like. It's totally up to you.
Okay, sure.
Okay. Could you implement?
Yeah. So I guess for simplicity, the first function we need is to determine whether a character is a vowel or not.
Okay.
So we need can I use C++?
It's up to you.
Okay.
Which language do you like?
I prefer C++.
Okay, please use C++.
So let's say we have a Boolean function,
Okay.
which returns a bool and is, well, did I spell correctly?
Yeah. Yep.
I guess so.
Yep.
So takes in a char,
Mm-hmm.
determine, so basically return C equals to, is that like lowercase or it can also be uppercase?
You can assume it's all lowercase characters.
Okay, cool. Or C is equal to A, E, or C is equal to I, or C is equal to O. And the final case is C is equal to U. I think I covered all the vowels.
Yes. Yeah, those are 5 vowels
So
in alphabet.
I think this function will give us the info whether a character is a vowel or not.
Okay.
And I think it's better to do it in place because it saves memory.
Mm-hmm.
So I guess so what kind of function can I assume I have? Can I take in a string as a parameter?
It's totally up to you. It may be character array, it may be string. It's totally up to you.
So how about like I take in a string and return a string?
Okay.
Yeah.
Yep.
So suppose we have a string and
Mm-hmm.
what is like the name can be like reverse, I guess. And also takes a string as a parameter
Okay.
and s.
Okay.
So what I'm trying to do is like we have 2 pointers. One pointer starts from the beginning, and the other pointer starts from the end, and we keep doing it until these 2 pointers reach to each other. Until these 2 pointers reach to each other.
Okay.
If both of them reach the wall, we swap those 2 walls.
Okay.
And I keep going forward until they meet each other.
Okay.
And then I'm done.
Okay.
So let's say we have 2 variables. Left, which is 0, right, is equal to s dot size. Can I assume this string is never an empty? It can be an empty string. It's never a null pointer. It's not going to be a pointer. Okay.
Well, actually, the input string may have some characters other than alphabets.
Yeah, that is fine.
Okay.
It doesn't matter here.
Yep.
So what I can do is we can do a for loop. I can do a while loop. While left is less than right. So yeah, first I want to find the first wall going from left.
Mm-hmm.
So there's another while loop inside, left less than right, and also not is wall as left. So this will keep doing so until I find a wall. So
Okay.
L plus plus.
Okay.
Actually, yes. But this one will return you the pointer to the pointer points to the character which is after the wall.
Mm-hmm.
So I need to minus L here.
Okay.
And I'll do the same thing for the right side. It's also left less than right. And not is wall. That's right. Right minus.
Okay.
And right plus plus. And there are several cases. The first case is both of them finds a wall, and now I swap it.
Mm-hmm.
And the second case is both of them meets at the same wall.
Mm-hmm.
Then I can either swap them or do nothing.
Okay.
So it shouldn't cause an issue.
Okay.
And the third case is the entire left string doesn't have any wall here.
Okay.
So they just go past by each other.
Mm-hmm.
So no matter whatever case it is,
Mm-hmm.
we can simply check if the SL and S right is a wall or not. If both of them are a wall, we can we can just swap them.
Okay. Yes.
So after that, we can do a if check. Is wall SL
Mm-hmm.
and is wall. That's right. Then we can swap. I think that's pretty much it. And then finally we can just return S. Yeah.
Okay, great. So like in this case, you called is vowel for the same character
Yes.
twice, right? Here.
Here?
Yes, you just check every character if this is vowel or not. If it's not,
Yeah,
if
yeah.
it's vowel, you're gonna have like the index L will be the pointing
Yes.
to the vowel character. And again, for the same vowel character, you're gonna call this is vowel function again, right?
Yeah, yes.
So, is there any way to reduce the calling is vowel function
Oh,
just once?
you are saying like the is vowel function is heavy loaded and you want to
Isn't-
reduce its reduce the number you call it?
Yeah, I think you are calling this vowel function twice for the same character.
Sure.
Actually, He's calling his vowel for the his vowel function multiple times because you have one here, you have one there, and you're gonna call it twice.
Yes.
Right.
And the easy way is it's not gonna call too much twice, right? It's only gonna call like the maximum number of calling is 2 times n.
Yes.
So if you want to reduce it, let's say like its vowel function is very costly, so we can have a we can have an array to record whether for a certain character, like in this string, its result.
Okay.
So we can, if we turns out to visit, like maybe we can put this into a hash table, like of length 26, because we only have 26 characters.
Okay.
And it's a Boolean array, right?
Okay.
It simply contains if it's a vowel or not, and then we can just return check the Boolean array.
Okay.
Yeah.
Yep. Can you check if your code is correct?
Yeah. Let me make sure of it.
Can you go through your code line by line? Everything?
Yeah, sure.
For like if any example here.
Let's do Apple.
Okay.
So initially, L is points to A, and actually, yeah, this is incorrect.
Okay.
Yeah, it should be size minus 1.
Okay.
So this is L, and yeah, let me go here. And this is right. And so the first thing is wire left less than right. So left is 0, right is 4. So we keep going forward until finds a vowel. So L will stay in 0 here because it's already found. Yes, I should erase these 2 lines. Never mind. Yeah. So until I finds a vowel, so L will stay in, because initially S0 is already a vowel here, so this line will not trigger. So basically L will still be 0, and after this line, right will also be 4, because S4 is a vowel.
Okay, so this vowel will be true for when L is 0.
Yeah.
This is true, this is false, so it will not increment. It will, and for the L is 4 this is true, this is false, so it will not increment.
Yes.
So L is 0, R is 4.
And then
you are here.
Yeah, and then it comes to here, and both of them are a vowel. So we're gonna swap them.
Okay.
So basically we swap S0 and S4.
Okay.
And the string becomes EPPLA.
Okay.
Damn. I should. Yeah, after swapping, I still need to increase L and right, because otherwise it's gonna stuck in the infinite loop over here.
Okay.
So what I'm gonna do is, after swapping, like add a line here. Let's say add here. After the if condition, simply do L plus right minus.
Okay.
So if we add this line here, and then so L becomes 1 and R becomes 3, and you are and after the second time doing the loop, like L will become 4.
Okay.
And R will become 0. So which means I have to another check here whether L is less than right, then we do the swapping. Otherwise, like it's still gonna swap.
Okay.
So yes, so I need to do a.
Wait. Do you have increment to add an L and decrement R? So L is 1, R is 3, and then you are here. L is 3, L is 1,
actually,
and there is vowel is P is not vowel. This is true. So it will keep increment until it becomes 3.
Probably
right?
we don't need that check here. No, L will become 4 eventually.
No, L is already 3.
Oh yeah, it's gonna be less than R.
Yeah.
Yes.
So it is once it becomes 2, and then once it becomes 3, and then 3 is less than L. It's not false. It's not true. So it will exit here, so and then it will exit here next.
Yeah. So then we'll return a string. So
okay, great.
I don't need that check over there.
Okay, great. And now the code it works. I think it works.
Okay.
Okay.
Cool. Yeah.
Another question here is that can you make this simpler?
By simpler, what do you mean? Like, it depends on the goal of this. Because the reason I write this code is because I don't want to use extra memory.
Okay. Yeah.
So
yeah.
if it's allowed to use extra memory, we can do something easier. Basically, take out all the balls, reverse the array, and put it back.
Yeah. The reason why I'm asking is that here L plus plus is there, and plus plus is there too, and L minus minus is here, and L minus minus is here too.
Yes.
So is there any way to just have one L increment and L decrement?
Sure. Yeah, there should be a way.
And the actual calling is vowel here and here, here and here. Of course, the 2n is the worst case.
Yes.
Do you think of any simple?
Let me see. Yes.
Because at the initial stage, you're pointing here, right?
Yes. How about initially you point to -1 and this points to sides, and then initially you are in the position from previous loop, and then you can use a do while here. You always force it to increment at least once. Then you can move this line.
Okay.
I don't think it reduces the simplicity of the code because I personally don't like do while like word. Like
okay, makes sense. All right.
And if you want to reduce the is vol here, it's kind of hard.
Okay.
Or if you don't want to call this function, you can just call it if L is less than R.
Okay.
It also works because the only case like these two, either of these two is negative, it should be L is equal to R.
Okay. Okay.
Yeah.
Can you tell me the complexity of this algorithm?
It's order of n.
Okay. How about the memory?
It's order of 1.
Okay.
Unless you need a string to parse in.
Yes. Okay. That's correct. Yeah. This is great.
Okay. Cool.
I have another question. Okay, let me stop here. We're going to continue the remaining part in the next session.